Okay, 4.2 on radians and degrees. So first off, we're going to look at angles, and when you learned about angles in geometry, you didn't necessarily talk about the initial side or terminal side. You just knew that there were two rays that met at a vertex, and the angle was the measurement between those two rays. Well, the initial side is the side that starts the angle, and terminal side is the ending side, which is important for us in PRECAL because we are looking at the application of geometry in algebra. So when we talk about an angle in standard position, we're going to position our angle so that the initial side is on the positive x-axis, and then the terminal side is going to be somewhere else on the coordinate plane. Okay, so at standard position, the initial side is on the positive x-axis. Okay, when we measure an angle, we're going to measure counterclockwise from that initial side. That will give us a positive measurement. If I measure clockwise from the initial side to the terminal side, then that would be a negative angle. Okay. Sometimes we're going to see a degree measured in degrees, minutes, and seconds. And this is just a precise measurement for angles instead of using a decimal that's been rounded. So when the Greeks invented these angles thousands of years ago, their number system was in base 60, not base 10 like ours is. Excuse me. So all of their measurements are in 60s. So 60 minutes in an hour, 60 seconds in a minute. That's where all of this comes from. So when I have a measurement of 32 degrees, 5 minutes, and 28 seconds, we can convert that to a decimal by doing this. We take the whole number, which is the degree, plus the minutes times 1 over 60, plus the seconds times 1 over 60 squared. Okay, since we're talking about there are 60 seconds in a minute and then 60 minutes in a second. Okay, so if you type all of this in your calculator, you're going to get 32.091 degrees. Okay, so we need to be able to go both directions with degrees and minutes and seconds. If I'm given those, I can convert it to a degree as a decimal. Or if I'm given a decimal, I need to be able to convert back to degrees, minutes, and seconds. So let's look at an example. So in part A, I have 329.125 degrees, and I'm supposed to convert that to DMS. So we're going to take the whole number, 329, that's our degrees. Okay, then we're going to take our decimal, 0.125, and we're going to multiply times 60. So when I do 0.125 times 60, I get 7.5. Well, I take that whole number, 7, and that's going to be my number of minutes. Okay, and then the decimal that we had was 0.5, so again I'm going to take the decimal amount and multiply times 60, and that's going to give me the number of seconds, which will be 30 seconds. So for this angle, 329.125 degrees is the same as 329 degrees, 7 minutes, and 30 seconds. Another way that you can use your calculator as well is if you type in 329.125 and then on your calculator you type second and the apps button, option 4 is DMS, or to convert to DMS. So after you hit enter, then it's going to take that decimal and convert it to degrees, minutes, and seconds for you. Now, unfortunately, the calculator doesn't work the other way, and we can't convert backwards. So for part B, we're actually going to have to do the math here. So I'm going to take 35 degrees plus, I'm going to take my 12 minutes and multiply that times 1 over 60, plus my 7 seconds and multiply times 1 over 60 squared. Okay, so when I type that in the calculator, I'm going to have to round, but I believe this is 35.202 degrees. Okay, so that's how you convert between degrees as a decimal and degrees, minutes, and seconds. Okay, so the next thing that we're going to look at is the radian measure, and it's just another way to measure an angle. So it says the measure theta in radians of a central angle of a circle is equal to the ratio of the length of the intercepted arc S to the radius of the circle. So this radian measurement is equal to the ratio of the arc divided by the radius of the circle. So I'm going to show you a little graphic here that will help explain, and I'll talk you through it. So we're going to start with a radius and draw a circle. This radius is going to be a measure R. If I take this same measurement and put it on the edge of the circle, that is the arc of the circle. That arc and the radius are the same length, so when I divide those, that equals a radian, or 1 radian. And as I rotate those radians around the circle, it turns out that there's just a little more than 3 radians halfway, actually pi radians. So then if I go all the way around the circle, then that would be equal to 2 pi radians. Okay, so I'm going to let it play through this one more time and re-explain. So again, we start with the length, which is the radius. We draw a circle. This length, radius r, is the same as the arc length on the edge of the circle. I make those the same. And radians is the ratio of the arc length to the radius of the circle. That would be a radian. So if I rotate these radians around the circle, it turns out there's a little more than 3 radians that goes halfway around. So 3.141592 radians. And if I continue going around the circle, then that would make it 2 pi radians all the way around the circle. So the important thing to remember here is that when we're converting between degrees and radians, that if I have a degree measurement and I want a radian, I'm going to multiply times pi over 180. If I have a radian measurement and I want to convert to degrees, I'm going to multiply times 180 over pi. Okay, so let's look at a couple of examples converting between radians and degrees. So the first example, part A, I have 135 degrees and I want to convert that into radians. So I'm going to multiply times pi over 180. Now I'm not actually going to type pi in my calculator because I don't want the decimal 3.14 to be multiplied out. I want to leave pi in my answer. Okay, so what I'm going to do is do 135 divided by 180 and just reduce the fraction. So if you do 135 divided by 180 and then do math, enter, this reduces to 3 over 4. So that means 135 degrees is the same thing as 3 pi over 4 in radians. Okay, so I wasn't very smart when I picked this other example. I wasn't thinking ahead, but I'm supposed to convert negative 3 pi over 4 into a degree. So when you're converting from radians to degrees, you're going to multiply by 180 over pi. So I always think of it this way. We want our pi's to go away, so those are going to cancel. And then I would multiply negative 3 times 180 divided by 4. And hopefully you're smart enough to realize that this is going to be a negative 135 degrees. Okay, so it's real easy to convert between the two. Okay, so the next thing we're going to look at is coterminal angles. Two angles can have the same initial and terminal sides but different measurements. These angles are called coterminal. So in the first picture here, it says positive and negative coterminal angles. I have angle alpha that would be a positive angle going counterclockwise, and angle beta that is a negative angle going clockwise. They start and stop at the same spot, so they are called coterminal angles. One thing to remember about coterminal angles is that they add to equal 360 degrees. Okay, the other option over here on the right are positive coterminal angles. Both of these start and stop at the same spot. Angle alpha is an acute angle that just fits in quadrant 1, while angle B, or beta, goes around one time and then a little bit more. So that angle would be bigger than 360 degrees in this case. Okay, so here's the rule on coterminal angles. If the angle is in degrees, it says if alpha is the degree measure of an angle, then all angles measuring A plus 360 n, where n is an integer, are coterminal with A, or alpha. So all that means is that we can add 360 degrees, we can subtract 360 degrees an infinite amount of times, and that will continue to give us coterminal angles. In radians, if alpha is a radian measure, then all angles measuring alpha plus 2 pi n, where n is an integer, are coterminal with A, or alpha also. So same thing, since 360 degrees is equivalent to 2 pi in radians, I can add 2 pi infinitely or subtract 2 pi infinitely to come up with other coterminal angles with the angle that we're given. Okay, so let's look at an example 3 where we are finding coterminal angles. So it says find one positive and one negative angle that is coterminal with 80. So what I'm going to do is I'm going to take 80 degrees and I'm going to add 360 degrees to it. And then I'm going to take 80 degrees and I'm going to subtract 360 degrees. I could do this and keep adding 360 degrees and find more and more coterminal angles, but they just want me to have one of each, okay? So if I add 360 degrees to 80, then I get the angle 440 degrees. If I subtract 360 from 80, I get the angle that is negative 280 degrees. So these angles are coterminal with 80 degrees because they both start and stop at the same spot. Okay, same thing for part B. We have an angle negative pi over 4, and we're supposed to find a positive and a negative angle that are coterminal. So I'm going to take the angle that they gave me, negative pi over 4, and I'm going to add 2 pi to that angle. And then I'm going to take negative pi over 4, and I'm going to subtract 2 pi. Okay, so don't let the pi's or the fractions scare you. We're just going to work this out pretty simply. In order to add or subtract fractions, they have to have a common denominator. So in this case, our common denominator is 4, so I'm going to need to multiply both of these by 4 on the top and the bottom to get an equivalent fraction. So for the first one, negative pi over 4 is going to be added to 8 pi over 4. And we'll figure out what that is in just a second. And then we're going to do negative pi over 4 minus 8 pi over 4 to find out our coterminal angles. So if I have negative 1 pi over 4 plus 8 pi's over 4, you can kind of ignore the pi's a little bit. So negative 1/4 plus 8/4 is going to be 7 pi over 4. And then when I do the second one, negative 1 pi over 4 minus 8 pi over 4, this would be negative 9 pi over 4. If you can, remember to reduce your fractions and simplify, but these two angles would be coterminal with negative pi over 4. Okay, next thing we're going to look at is the arc length. Arc length on a circle is like the crust of the pizza. It's the length around the edge of the circle. So it says if theta is a central angle in a circle of radius r, the length of the intercepted arc s is s equals r theta, and theta is measured in radians for this formula. Okay, so if I'm solving for the length of that arc, all I have to do is multiply the radius times the angle measure that they gave me in radians. So example 4 says find the length of the intercepted arc in a circle with a radius of 6 centimeters and a central angle measuring pi over 4. Now, if they had not given us the angle measurement in radians, then I would have needed to convert to radians first. So S equals r theta. We're going to plug in our radius is 6 times our angle, which is pi over 4. So S is going to equal 6 pi over 4, and we're just going to type this in our calculator and find out approximately the length of the arc. So if I do 6 times pi divided by 4, then this arc is approximately 4.71, and I believe they said centimeters is the measurement that they use for the radius, so that's the measurement we're going to use for the length of the arc as well. Next is the area of a sector. So a sector is kind of like a slice of pizza on the circle. It's a section of the circle. It says if theta is a central angle in a circle with a radius r, the area of the sector is 1/2 the radius squared times theta, which is the angle, the central angle of the circle. And again, theta is measured in radians. Okay, so let's look at this example, 5. It says to find the area of the sector of the circle. So the formula is A equals 1/2 times the radius squared times the angle theta. So it's going to be 1/2, our radius is 5 squared, times our central angle, 3 pi over 4. So I'm just going to do a little bit of simplifying. This is 1/2 times 25 times 3 pi over 4. We could do some more simplifying, and this would wind up being, if I multiply straight across the top, 75 pi, and then straight across the bottom over 8. So in my calculator, I'm going to do 75 times pi, and then divide by 8. So the area of our sector is going to be approximately 29.45, and since this is area, this will be meters squared.